Okay, so the next thing we're going to go through is through Kc. There are a couple of different types of questions that you can get. I'm going to show you how to go through each one and what they're looking for in their answer. So first things first, Kc stands for the equilibrium constant. The expression for Kc is products over your reactants. So if you look here as to what I've highlighted in green and look at this general equation here, you can see from the equation that your products are your D plus E and your reactants are your A plus B. So the way we work out Kc is by putting products multiplied together over our reactants multiplied together. And our products are to the power of whatever number is in front of them. So, for example, going back to the Haber process, if I have an equation like 3H2 plus N2 goes into 2NH3, it's going to be products over reactants, just like we had in our example over here. So now looking at our equation, our products is NH3 over H2 multiplied by N2. We multiply them together. Now, what do we do with the powers? In front of the NH3 is a 2, so we're going to put NH3 squared. And in front of the H2 is a 3, so we're going to put H2 cubed. In front of N2 is a 1, so that's fine. And this is how you would write an expression. So if in the exam they tell you write an expression, then this is what you write. You're just going to do products over reactants, and the products and reactants are to the power of whatever number is in front of them. Okay, take a look at this orange question here. This is a common type of question you can get in your exam. If we have 0.2 moles of potassium PCl5 and that decomposes, each equilibrium mixture contains 0.08 moles of PCl3. Write an expression for Kc and calculate Kc. Okay, this is a common type of question that you can get. For the first part, you should be able to do it now. How would you write your expression of Kc? Once again, it is products over reactants. So it's the concentration of PCl3 multiplied by the concentration of chlorine, and those are your two products. You multiply them together over our reactant, which is PCl5. Because everything in the equation has a 1 in front of it, it's all going to be to the power of 1. Okay, once we've done that, how do we actually calculate Kc? Here we use something called a Rice diagram. I'm sure many of you have had this before in school, where your R stands for your reaction, so put that next to your reaction. Your I stands for your initial, C stands for change, and E stands for equilibrium. Okay, now one important thing that you have to know is in this expression that you wrote, the square brackets mean concentration. So in the expression, when we say the concentration of PCl3 multiplied by the concentration of Cl2 divided by the concentration of PCl5, the concentration that we're talking about is the concentration at equilibrium. Not the concentration we had at the beginning, the concentration at equilibrium. So what we need to do is look at how much we had initially and how much it changes over the reaction. So for example, we read the question and we see that it says 0.2 moles of PCl5 decomposes, meaning this 0.2 moles is how much we had initially before it decomposed. So under I, we would write 0.2 for PCl5. For PCl3 and for Cl2, both of them, because there are products, initially we would always have 0 for our products because the reaction has not yet started. So it wouldn't make any sense that we have any products, because if the reaction hasn't started, then we haven't produced any products. So that's why our initial for our products is always 0. We skip this C and we go to the equilibrium. We look back at the question and we say that the question says at equilibrium there is 0.08 moles of PCl3. So we can fill in over here PCl3 0.08. And from here on out it's just basic maths. So we look, how do we get from 0 to 0.08 for PCl3? The difference is we added 0.08. So the changes add 0.08. The change for Cl2 would be the exact same, add 0.08. Now the change for PCl5, because it's a reactant, with time, reactants are used up. So instead of adding 0.08, we minus 0.08. And now we just do simple maths. So we're left with 0.12 moles of PCl5 and 0.08 moles of Cl2. After this, to actually calculate Kc, we just substitute in our values. So our PCl5 goes here, our 0.08 goes there, and our other 0.08 goes here. and that is now equal to 0.08 multiplied by 0.08 divided by 0.12, and whatever we get, that is our answer. And this is basically how you solve any KC question. So hopefully that makes sense. If any of you are confused, just leave a comment down and I'll answer it there. Okay, the answer would be 0.53 for this one. Now, in terms of units, it can be like another 1 marker. How do you calculate units? Well, calculating units is very simple. In this equation here, you know that these square brackets represent concentration. They will give you in the question what the concentration is measured in, but it's usually measured in mole per decimeter cubed. So mole dm minus 3. Now, you look at what you multiplied at the top and what you had at the bottom. We had the concentration of PCl3 times by the concentration of Cl2. So substitute in the units for each one. So that's mole dm minus 3 multiplied by mole dm minus 3. And at the bottom, we just had the concentration of our reactant, which is just one reactant. So it's just mole dm minus 3. We're not multiplying by anything because there was just one here. Then these cancel out, and what you're left with is mole dm minus 3 over 1. So what you can do is you can just flip it around. So it becomes, actually no, you would keep it for this one. So it would just stay as mole dm minus 3. Okay, if any of you are confused, just let me know in the comments and I'll explain it again. Okay, the next thing to go through are what factors affect the value of Kc. Once we have established that Kc is products over reactants, then this shouldn't be too confusing. The first thing is, if you watch my previous video where I went through what factors affect equilibrium, an increase in temperature will cause equilibrium to shift to the endothermic side. So if you look at this equation, this question here, I've purposely written delta H is equal to positive, meaning delta H enthalpy change is a positive value. This tells you that delta H is an endothermic reaction because it's positive. So if we increase the temperature, an increase in temperature will always cause equilibrium to shift to the endothermic side, which in this case is the forwards reaction, since the forwards reaction is endothermic. So the equilibrium will shift right. Now, from the previous video, make sure you check out if this isn't making too much sense. I explained it in a lot more detail there. If equilibrium shifts to the right, this now means the forward reaction is a lot faster. Therefore, if the forward reaction is a lot faster, that means we're producing more products and we're using up more reactants. Therefore, the concentration of products increases and the concentration of reactants decrease. If this is the scenario, then obviously now there's a greater number at the top, there's a greater numerator and a lower denominator, so therefore Kc will increase. So this is how you can work out how does temperature have an effect on Kc. Look at where it shifts. If it shifts to the right, Kc will increase. If it shifts to the left, Kc will decrease. And the way you figure out whether it shifts right or left is by looking at whether it shifts to the endothermic or exothermic side, and then looking at whether or not the question that they've given you, whether it's endo or exothermic. It's all explained in the previous video. Just make sure you refer back to that if you're still confused. The easy thing is there's no effect. Concentration has no effect. And adding a catalyst also has absolutely no effect on it because it increases the rate of the forward reactions and the backwards reactions by the same amount. So equilibrium does not shift. Okay, I've given you one extra question here. This is a different type of question you can get. In this type of question, basically you just have to rearrange and you just do everything in a bit of a different order. So the first thing is they've already told you the Kc. They've already told you the Kc. Note, they've also given you delta H as well, so just keep that in mind. And here, because delta H is negative, what does this tell you? That it's an exothermic reaction. Okay, the question says, using your value of Kc, explain whether the equilibrium position will be towards the right or towards the left under these conditions and calculate the concentration of SO3 in the equilibrium mixture. Okay, forget about part A. I'm just going to focus on part B first, calculating the concentration of SO3. So, again, how do we start off the question? Write out an expression first. We know that Kc is equal to products over reactants. So the product is SO3, and it's SO3 to the power of 2 because there's a 2 in front of it. So SO3 squared over the reactants, which is SO2 to the power of 2 times by O2 just by itself because there's no number in front of it. Okay, once we have this, all we're going to do is we're just going to plug in our numbers. Now, we already know Kc, we already know SO2, and we already know the equilibrium concentration of SO2 and O2. We're asked to work out SO3. So here we're actually going to rearrange the equation instead. So we're going to do Kc multiplied by SO2 squared multiplied by O2, and that should equal SO3 squared. Hopefully this makes sense. Again, if not, just leave a comment down and I'll explain it all there. Now, whatever we do after that, once we plug that in our calculator, so that would be 0.16 multiplied by the concentration of SO2, which is 2, squared. So 0.6 multiplied by 2 squared, multiplied by the concentration of O2, which is 1.2. And then whatever that answer is, we square root it to get the answer for SO3. And that would give you your answer. So this is how basically we answer all these different types of questions with regarding to Kc. Again, if you're confused, let me know and I'll be happy to explain it again. Also, why have I given this to 3 significant figures and not 1 or 2 or 4? The reason why is you look at your question. We are given 3 numbers here, 0.16, 2 and 1.2. When you have these numbers, look for what the lowest number of significant figures that the question has given a number in. So this was given in 3 significant figures. This was also given in 3 significant figures. And this was also given in 3 significant figures. So therefore, I'm also going to give my answer in 3 significant figures. You give it to the lowest to whatever the question has given it in. Hopefully this makes sense. Again, if you're confused, just let me know and I'll make another video explaining it in more detail if you need me to.